Hi, everyone. I'm Eiffel. Nice to meet all of you. I'm really happy to be here. It's my first time in Sydney, so yeah. All right, so I want you to close your eyes right now. Sorry. Okay, so picture the year 2030. What does it look like in Sydney? So this is what, you can open your eyes now. So according to DALI, this is what Sydney will look like in 2030. So when I saved this picture, I obviously have never been to Sydney, and I didn't realize that it was so wrong. But okay, so it's 2030, and Rails still exists, and you got a new job, and you're going to work, and because it's your first day of work, thankfully AI hasn't taken over our jobs yet, and you enter your office, and for some reason, your company still rented out this office even though no one shows up to work, and so you sit at your desk. And that's when you realize that the new company that you've joined is still on Rails 7.1. I can't believe we're still on Rails 7.1, Lamau, is what you want to text your manager, but obviously you don't. But you might be thinking, Rails 7.1, what a great release. We got Trilogy and composite primary keys. But to put things into perspective, that's like being on Rails 5 right now. So imagine the amount of security vulnerabilities your application is stacked up by then. And not to mention the cool Rails feature that you're missing out on. So if there's one thing I want you to take away from this talk, it is that it's never too early to show your growing Rails application some tender love and care. Okay? Regardless of the size of your team. And I know what you might be thinking. Tender love, right? So this is what you can expect from this talk. I'm going to share with you what the Rails infrastructure team does at Gusto, why you may eventually maybe need a Rails infrastructure team, some team philosophies that guide how my team approaches our work, and what we've accomplished as a team. And this is lessons from a Rails infrastructure team. So I work with Gusto, and I also work at a company called Gusto. They really make us say this. I work with Gusto. So Gusto is a software for payroll, benefits, and human resource management for companies in the US. And we have around 2 Rails applications, but today I'll be talking about our main Rails monolith. So our main Rails monolith was born in 2013. Fast forward to 2019, it is now 6 years old. It has 1.2 million lines of code, 538 models with 100 to 125 engineers working on it. This is like the continuation of Dimitri's talk from yesterday, where it's a large company in 2019 already. We were on Ruby 2.3 and Rails 4.2. So if you're familiar with Rails, you would have noticed that in 2019, Rails 4.2 is no longer supported, so it's a huge red flag there. So that was when the Rails infrastructure team at Gusto was born, except we didn't call ourselves that. We called ourselves the product infrastructure backend team. So it's kind of like the bridge between product development and the infrastructure behind it. And it started out with a couple of volunteers from various product teams around the company that saw a need for long-term application maintenance because no one was doing the work. There was no official team for it. And obviously, the team lead was very supportive and saw the benefits of that. And so the first unofficial project was upgrading from Rails 4 to Rails 5. So when I say Rails infrastructure team, in reality, it can also be known as other names, such as the Ruby and/or Rails infrastructure and/or architecture teams. Yes. So when I say Rails infrastructure, I mean like, teams that do that sort of work, and you'll see what I mean in just a minute. So that was 2019. Fast forward to 2024. We're now 11 years old, kind of old. 4.6 million lines of code, 1,800 models, with 400 plus engineers working on it. And we're now on Ruby 3.3 and Rails 7.1, which is great. We're on the latest Rails. So just a quick shout out to my team. At the moment, we have Josh, Calvin, Nan, Zener, and I, with Nan leading our team. I will be sharing the work that we all did. So you might be wondering now, like, what exactly does a Rails infrastructure team do? And people will say, we do the dirty work. It's the work that no one wants to do, and we do the work so that product engineers don't have to upgrade the app and all that stuff. But I don't think it is dirty work at all because I really enjoy it. I think that we make sure the application is healthy and the developer is productive. So here's a bunch of things that we own. I won't be going through all of it, but it can be broken down to 4 main categories. The first one, application maintenance. So this is like application security and ensuring that Ruby, Rails, and gem dependencies are maintained and updated. The next one is shared resource management. So our team is in charge of the background jobs infrastructure at Gusto. We manage the service level agreement queues and take care of resource allocation strategies, scaling, dynamic reroutes of jobs to ensure that all the queues are in good shape. The next one is developer productivity. So we make sure that developers can stay productive and ship their code in a timely manner through continuous integration build health, so ensuring that people can continuously ship, and development workflows. And the last one is application scalability. So for our team, we want to make sure that the application will continue to grow and scale properly. And that includes Ruby and Rails best practices across the company, as well as technology and library migrations. So here are some signs that you may need a Rails infrastructure team. And I put the Rails infrastructure team in quotes here because it's not necessarily just one team. It can be one engineer who really wanted to improve the health of your application. And it might be a couple of volunteers. So a couple signs is that you see an increasing build and infrastructure cost and time. You are potentially relying on deprecated or unmaintained dependencies. And in this case, it could be like a gem or just an outdated Ruby or Rails version. There's an increase in developer iteration cycles, redundant work done across teams, or damaging or inconsistent coding practices across the application. So with that, I want to share with you some team philosophies that may guide you in how you approach the work. And I know that my team use these philosophies to decide the work that we do at the company. So the first thing might be really obvious, but it's really important, is that we try our best to stay closely aligned with the Ruby and Rails ecosystem. And this is really important because it will ensure that we can seamlessly integrate future language and framework updates, maintain compatibility, and minimize potential future disruptions. So what that can look like is using the latest Rails configuration defaults. So whenever we upgrade to the latest Rails version, we make sure to also switch over to use whatever Rails configuration defaults it is for that version. And that can also be really informative to you because that is essentially what the Rails core team is deciding on how they want to drive the framework. The next one is to upgrade gem dependencies regularly. So again, this sounds really obvious, but it's really important. And I will talk more on that later. Use supported libraries and tools. So one example is that we recently switched from pry-bybug to debug. And debug is now obviously a supported library from Ruby core, so, and contains more rich features for debugging. We also make sure to remove any backports after upgrading to a new version. And finally, we do our best to stay engaged with the Ruby and Rails community. And that can look like many things, like supporting open source libraries, and also the next thing, which is finding opportunities to contribute bug fixes or issues upstream. So this is one of my favorite things to work on. Sorry, one of my favorite aspects to work on for the Rails infrastructure team, because there are also ways that we can, that I am personally able to grow as an engineer by working with folks from other companies and also open source maintainers. So there are two examples I wanted to share. The first one is when one of my teammates, Josh, ran a memory profile on the entire application and found that there were files that did not have this frozen string literal true magic comment because of an inconsistency of how files were excluded from the Rubocop cop in our application. But not having this comment enabled can lead to additional memory allocations, especially when methods are on a hot path. So he fixed that in our application, but he also saw an opportunity to do that in RSpec support when he ran the memory profile. So he put up a PR to also fix that. And I think that's pretty cool. So the next example, Nan introduced a new feature to Bundler to improve the Ruby method. So in the before, you can see that to input the Ruby version, we had to join .ruby version file, read it, and strip it. But now we can just specify the Ruby version file instead of doing that whole dance. So yeah, it's pretty cool to contribute upstream. So one of the another aspect of working on the Rails infrastructure team is that you get to work with product engineers across the company. So not only you're essentially working for them because you want them to be productive and be able to ship code. So at our core, we want to empower engineers to make good decisions. And that in turn will ideally benefit the health of our code and application. At Gusto, we generally try to avoid strict enforcement of rules, but exceptions are made when the rules or a certain practice poses a risk to code maintainability, scalability, or performance. So one example is we try to make it easy to do the right thing or make it hard to do the wrong thing. So the example is our restriction of Ruby's refinement. So if you didn't know, refinement is a Ruby feature that is an alternative to monkey patching. And the effects of monkey patching is global. And refinement allows you to only modify the class locally. So it is convenient and fun to use because it's Ruby. But it does make it harder to debug, especially when 400 people are working on like millions of lines of code. Refinement is also known to increase boot time and may be a blocker to future upgrades. So what we did was we restrict the usages of refinement in our code base with a Rubocop. So another thing that we do is when we want people to adopt tooling across the application is we try to increase the value proposition for that particular tool. So in our case, we wanted to introduce sorbet. We made it we didn't make it mandatory, so teams are able to opt in or opt out of using sorbet. But we made it really easy and beneficial for teams to type their code. So we saw that eventually people saw the benefits and started typing. So our application is mostly typed now. So jumping back to the whole part about upgrading gems and how it's important, one thing that we do is that we upgrade incrementally instead of all at once. So what I mean by upgrade incrementally is that we bump the software version one version at a time over like a week. So we gradually move from the current version to the next version. And comparing to a full upgrade, when you jump to one version to the target Rails or target version immediately. So we prefer incremental upgrades for various reasons. For one, the change set each time is smaller. So it is much easier to debug and mitigate risk if any problems arise, which it will, if your application is huge. And incremental upgrades also allow you to get the benefits of each version bump. So overall, we're kind of breaking up the work into smaller chunks over the year. And that can be done by one person, rather than tackling it all at once in like a full project and a full upgrade with potentially multiple engineers. And that feels like a good trade-off. But the key is to have a pipeline. So what we have right now in our gem file is we're on Rails 7.1, but we don't point to the version, we use the branch 7.1 stable. So 7.1 stable branch contains the commits that will eventually be released in the next patch version of 7.1. So it contains like potentially bug fixes or security vulnerability fixes. And so we have a bot that goes and run bundle update Rails every week and generates this PR. So all we have to do, or what I usually do, is I go look at the change log, and if CI is green and everything looks good, we just ship it. Eventually, we hope to use Rails Edge, which is like the main branch, but currently we're just on 7.1 stable. So the reason why I'm able to just, if the CI is green, we can just ship it, is because we trust in the robustness of the CI build. So I think that's a really important thing and important value to have while working on the Rails infrastructure team. It's kind of like being a pilot. So when you're a pilot, you have instrumentation in the cockpit. And when you want to land a plane, you can't just look outside the window because there's nothing to look at. You have to rely on the instrumentation in front of you to help navigate and control the aircraft and ensure a smooth landing. Very similarly, we treat our CI build as those instrumentations where, okay, we need to ensure that our CI build is solid so that we can have all the information for a smooth landing. And a robust CI build is really critical to moving fast. So it should be able to catch issues through unit tests, smoke tests, integration tests before deploying to a higher production environment. So being able to trust in the robustness of the CI will make us more confident in the changes that we're making, which allows for quicker iteration. And this also applies to product engineers and also for our team, because I want to be able to ship any upgrades without manually testing all the changes in the gems or Rails or Ruby. And in general, we also try to avoid the need to have any manual testing. So we have like this question in our incident postmortem doc that encourages developers to think about ways that we can prevent that incident from happening by having a step to catch it on CI. So it's like, oh, how could we catch this incident or error in CI? The goal is to prevent the same incident from happening again. So one specific example is this environment CI check that we have on our build that boots up our application in various contexts and environments. So in this case, the one I'm highlighting is console development, where we literally just start console development because an engineer shipped something to production and it broke everyone's local dev. And so we're just ensuring that it never happens again. All right, so as you know, we have code, and in a growing application, we're gonna have more code, and we're good engineers, so we have more tests. But that leads to an increase in build time, build cost, and build complexity, which in turn will lead to lower developer acceleration. So one thing that our team does is we invest in libraries that will make long-term maintenance easier. So we use BuildKite as our CI platform. Let's go. I'm not going to say, BuildKite is great. I really enjoy BuildKite. So in the past, this is how our pipeline looks like. There's only two steps. One is the setup step, where bundler, database, and Webpack is set up. And then another testing step where all the Rubocop, sorbet, and RSpec tests run. But thanks to BuildKite's depends on feature, it now smartly determines which steps to run depending on the dependencies that step relies on. But it kind of leads to this ginormous pipeline.yaml file. So this pipeline.yaml file is from 2019. So we at Gusto created this library called BuildKite Builder. It is a Ruby DSL to programmatically create BuildKite pipelines. So instead of having this giant pipeline.yaml file, we have this slightly smaller pipeline.rb file. So this is all in Ruby, and and within those Ruby file, it points to various other smaller pipeline steps, and we get an improved pipeline organization. So zooming into one of these step Ruby files, the Rubocop step, you can see that this is Ruby, obviously, and you can more easily tell what this step is doing. So for example, the command this step is running, and the agent it's using, and the timeout. But comparing it to like the equivalent YAML file, it is much less readable, in my opinion, and it's also larger. So using Build Kite Builder also improved like pipeline readability. So the other benefit of using Build Kite Builder is that you get to conditionally build steps. So in our main Rails application, we have components. And a component is kind of like a Rails engine that can depend on other components. So what we do is that when there is a modified file in one component, we're able to trace what that component depends on, and only conditionally run the RSpec test for those affected components. And another example is going back to the Rubocop step, is that we skip the Rubocop step completely if there are no Ruby files modified. So for example, if you make a change to a YAML file, this Rubocop step is skipped completely. So we also get conditional steps based on runtime information. So having Build Kite Builder is actually pretty useful, because in the before, we get like a really large amount of steps, and after there are fewer steps that are being run. It is a faster build time because fewer steps are being run, and we also save a lot on infrastructure costs because the CI nodes don't have to boot up. So yeah, this is Build Kite Builder. If you're curious about it, I highly recommend checking it out. Rails CI is also on it, which I'm really proud of and really happy to see. Yeah, so the next thing is we want to optimize the feedback cycle on CI. So the first problem that we saw was that CI build times was really unreliable, even with the same change. So let's say given a PR with one change, if we run the build twice, the build times can range from 15 to 35 minutes. And that is not great, because we want our slowest test to be the bottleneck of the runtime, not like this unpredictable test suite. So there are various reasons for the varying RSpec runtime. So the first one is that we use Amazon EC2 spot instances to run our CI nodes, which means that the machine that runs our CI nodes can vary depending on what machine is available from Amazon at the time. So varying hardware and boot time will affect it. And running system and capybara specs will also result in inconsistent test time because of the external browser dependency, and also flaky tests that needs to be potentially rerun. So first thing we did is stabilize the CI build time by optimizing test parallelization. And we do that using a service called Knapsack Pro that allows us to split these tests evenly on parallel CI nodes dynamically. So this is the result of it. All the RSpec tests completes within 14 minutes. So alternatively, if we didn't have Knapsack Pro, what we would see is essentially like a step that runs like 20 minutes, and all the other steps runs in like maybe 14 or whatever. So now everything finishes more predictably. So the second problem we saw is something that is obviously expected with a growing application, is growing CI build times. So when a product developer puts up a PR, like a simple change in one file in a part of the application, we don't need to run the entire CI build. So given a list of change files, what is the minimum number of tests to run that will give us the maximum confidence whether or not the change is safe to merge? So we developed something we call test mapping, implemented using Ruby's trace point. So we want to be really smart about what tests we're going to run. So test mapping is generated from the main branch in a separate build pipeline, and it contains a mapping of the spec files to the Ruby files that is impacted. So what we do is we run the specs, and using trace point, we know which Ruby files are touched. And similarly, we have it for system spec files to front-end files. So on a pull request build, what we would have in this case is the input is the modified files of that PR, and we cross-map it to the latest test mapping that is generated, and then we get a list of spec files to be run. So this is actually, I think it's pretty cool, because now we have this build kite annotation for each build, and you're able to see, like, in this build, running 5 of total 17,000 tests based on just 2 modified files. So this saved us a lot of money and time. So in 5 days, we saved $5,000 and 68 hours of engineering time. So that's around like more than $250,000 a year. So yeah, we've done a lot of stuff to optimize our build, our CI build. So this is what it looks like from 2020 to 2024. And you can see that in 2020, the build time is 13 minutes, and in 2024, it's like 10 minutes. It doesn't seem like a huge improvement, but take into account the scale that we've grown since 2020 to 2024. So, the increase in test suites and amount of developers working on the application. So obviously, this is not going to be a solved problem, because as time passes and the code increase, we're going to have to potentially revisit this again. So I just wanted to point out that doing maintenance work for an application can be pretty thankless. If you do it well, no one's gonna notice because everything's just going smoothly. So I wanted to point out some more solid impact of the team. So the first thing is that we're now using the latest OS Ruby and Rails versions, and this is really cool. I think it's really cool and important because we've avoided a lot of security issues by just being on the latest versions. And also having the pipeline to quickly upgrade if we need to. We've upgraded to Ruby 3.3 within 1 month of its release. We've upgraded to Rails 7.1 within 5 months of release, and that is with 2.5 engineers working on it on the side. We're now using Ruby's YJIT, which is the just-in-time compiler. And we're also now on the Trilogy database adapter, which is more performant and allows us to remove some MySQL dependencies. We've also, since then, deprecated various unmaintained libraries, which, as you know, is going to be inevitable considering the age of the Rails application. And really important for us to be able to continue to scale, because we don't want developers to continually use deprecated libraries. And we've also, since then, improved application tests and boot time, improved the processes to run background jobs, data and schema migrations, and rake tasks, reduced the average CI build time from 30 minutes to 10 minutes, and lastly, this is my favorite one, reduce incident related to background jobs latency queues from 2 to 3 times a week to 0 at our peak. So I think that's really cool. You might be thinking, our application isn't as large. Do we really need all of this? But I think, and I hope that it will be. So it is best to start thinking about it now, or thinking about ways to set up these processes and pipelines to better scale the application. So yeah, as I said, it is never too early to show your growing Rails application some tender love and care. I hope I gave you some ideas on how you can start thinking or working on that. But yeah, thank you so much, and thank you to my Ruby friends for emotionally supporting me in this talk. And thank you for being here. I would love for you to ask me questions or talk to me after about anything, or even share your own setup if you have. Yeah, thank you.